So this is a video for lesson 80, which is about geometric sequences. And I should start off by explaining what a geometric sequence is. A sequence is a list of numbers, but what makes it geometric, rather what a geometric sequence is in differing from an arithmetic sequence, is that a geometric sequence is a collection or list of numbers with a common ratio or multiplier. So we're multiplying as we go from term to term. And here's the explicit notation. This can be found on your reference sheet. A sub n is equal to a sub 1 times r to the n minus 1, where r is the common ratio or multiplier. If you're missing any of this in your notes, you should write this down. Now let's do an example, since we get the hang of sequences to some extent already. Now, the instructions for the first section is to find the first 5 terms. Okay, so find the first 5 terms. Now I'll walk you through what that looks like. To find the first term, for the first term, n equals 1. N is your number in line, so for the first term, his number in line is clearly 1. So when I plug in 1 for all the n's, I get a sub 1 is equal to 4 times 3 to the 1 minus 1. I can simplify that 1 minus 1 and make this 4 times 3 to the 0. Well, 3 to the 0, anything to the 0 is actually equal to 1. So we get 4 times 1, which is 4. And that's our first term. To get our second term, we plug in a 0. Rather, not a 0, a 2. Plug in a 2. So I plug that in, 4 times 3 to the 2 minus 1. And that's equal to 4 times 3 to the 1. And that is 4 times 3, which is 12. We'll do one more, a to the third, a sub 3. I get 4 times 3 to the 3 minus 1, which is 4 times 3 squared, which is 4 times 9, which is 36. Now, if you haven't noticed the pattern, this right here is my first term. And this right here is my r. Rather, they like to use lowercase r. So it's my common ratio, my common multiplier. So what am I multiplying by every time? That. So my numbers are 4, 12, 36, times 3 gets me 108, times 3 gets me 324, ... And that's the first 5 terms of the sequence. Now let's do one with a little less work to it. Example number 3 right on the front. Now this one might be a little tricky if you don't notice that this right here is r. So what multiplier, what coefficient do I have in the front? It's a 1. Now if you plug in the same way we did for number 2, you wouldn't have any issues with this. But in general, if there's missing a term, it tends to be a 1. So in this case, my first term is going to be 1. What am I multiplying it by every time? Negative 3. So 1 times negative 3 is negative 3. Times negative 3 again gets me positive 9. Times negative 3 gets me negative 27. Times negative 3 gets me positive 81, comma, ... And that can all be made a little bit simpler if you have a calculator on hand to do the multiplication. Now let's move to the next section. Starting at question number 10. Our goal now is to find the explicit formula, and we're given some of the numbers. So they give us negative 2, negative 12, negative 72. When you look at those numbers, you should see that they're not the same distance apart from each other. So this can't be arithmetic, right? From here to here would be minus 10, but from here to here is minus 60. Well, that doesn't look right. That's not arithmetic. We must be multiplying by something. So the question is, what are we multiplying by? Well, if you want to find this out and you're not sure, you can take any 2 terms and think of it like this. To get from negative 2 to negative 72, we multiplied by r. That's what r is, the multiplier. So therefore, negative 12 times r must be equal to negative 72. So I divide by negative 12 on both sides to get r by itself. And I get that r is equal to positive 6. You can confirm that. Negative 2 times 6 is negative 12. Negative 12 times 6 is negative 72. Yes, that seems to work. And I also need, now that I have r, I need a sub 1. Well, that's just going to be negative 2. A sub 1 equals negative 2. Now when I plug those in, I have the explicit formula. A sub n equals negative 2 times 6 to the n minus 1 power. And that's the explicit formula. If you have any issues in this section, just watch that through again, because that exact process can be used for any one of these in the section. Now, let's move on to question 18 on the back. I'm going to erase this strategically. Okay. So for question 18, our instructions are to find the first 5 terms. So finding the terms. Now, I want to read these rather than plugging them in. You can plug them in, but it's a little messy. Now, a sub 1 is equal to 2. What that means is that the first term of a is 2. The first term of a equals 2. So if I'm going to write this out, I know that my first number is 2. Now, what does this rule up top tell me? The rule up top tells me that a sub n, so this is the nth term of a, or it could also be thought of as like any term. It's a generalized term. So any term is equal to the term before it, because its place is 1 less, times negative 4. So the rule is that to find any term, you get the term before it, and you multiply it by negative 4. So I know that my terms are 2 times negative 4 is negative 8, times negative 4 is positive 32, times negative 4 is negative 128, and times negative 4 gets me positive 512, comma, dot, dot, dot. Now let me do one more, and I'll do it the long way, just in case you're having any issues with this. I prefer to look at it as a sentence, but if you don't like it as a sentence, we can do it by plugging in as well. So let me just rewrite this. I'm going to want to take this over to my loose leaf. A sub 1 is equal to 1, and a sub n is equal to a sub n minus 1 times 6. So this is question 19. Okay, now if I want to find the first 5 terms, I have a sub 1. What else do I need? I'm going to need a sub 2. I'm going to need a sub 3, a sub 4, and a sub 5. Now, the formula says that a sub n is equal to a sub n minus 1 times 6. So if I want a sub 2, that means that n must be 2. So I would get a sub 2 is equal to a sub 2 minus 1 times 6. If I simplify this, I can make this into a sub 1 times 6. And wait, we actually know a sub 1. So I can substitute that in. So this is equal to 1 times 6, which is 6. And that is a sub 2. I'm going to switch my color. If I want to find a sub 3 is equal to a sub 3 minus 1 times 6. 3 minus 1 is 2, so this is a sub 2 times 6. And wait, I actually know a sub 2. It was right here, so I can just plug that in, and I get 6 times 6 equals 36. The same pattern happens. I'm only going to do one more. If I want a sub 4, can you tell? A sub 3 was equal to a sub 2 times 6. A sub 2 is equal to a sub 1 times 6. So a sub 4 is going to be equal to a sub 3 times 6. Well, I know a sub 3. A sub 3 is 36. We just found that. Times 6 is going to get me 180, 216. Now you'd want a calculator to finish off this question, and I don't care to switch to mine. The first three numbers are 6, 36, 216, and then there will be two more terms that you'll find by multiplying by 6, and you throw a dot 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 on the end, and that'll be your final answer. So I hope that helps. If that seemed more confusing, you should go back and watch the explanation for question 18 again and try to commit that concept to memory instead. So see you in class.